Question 9. Consider this function for x between 0 and pi. Show the x-coordinate of the minimum on this curve satisfies this equation. So let's find the x-coordinate for that minimum. First thing we're going to do is we're going to get the derivative, which means we need the quotient rule. Okay. We're going to call our u is going to be x to the 1/2, because that comes from our square root, same thing up there. And our v is going to be sine of x. So dv dx is going to be the derivative of sine is cosine. And du dx would be 1/2 x to the negative 1/2. And then we're just going to plug it all in. And we're going to get v. So sine of x times the derivative, which is 1/2 x to the negative 1/2 minus u, which is x to the 1/2, dv, which is cosine, all over v squared, so sine squared of x. Okay. Let's simplify this a little bit. So what I'm going to do is I'm going to write this out. Oh, this is y prime. Y prime is going to be sine of x over square root of x times sine squared of x minus square root of x cosine of x over sine squared of x. And then I can get rid of at least one of those. So I would just be left with over here. Oh, and then I can't forget about that 1/2, my bad. So I got a 2 here. 1 over 2 root x sine x minus cosine x root x over sine squared of x. Okay, just a little bit easier to work with. Then we're going to set it all equal to 0 so that we can find out where that minimum is. I just added this bit. Oops, sorry, wrong thing. I added this to the other side. Then multiplying both sides by the denominator. So sine squared got moved over here, and this guy got moved over here so that we could simplify a fair bit. We can get rid of one of these sine of x's. So now we're just left with sine of x over here. So I got rid of that like squared there. That's what happened. And these two x's together are just going to give me x. So that's going to give me 2x cosine of x. And then, oh my gosh, we're so close, because remember what we're supposed to show here is that this satisfies 2x equals tangent of x. Well, if we divide by cosine and divide by cosine, then we get 2x equals tangent of x. Giant check mark. Cool. Okay, back up to the problem. That was just part A. Okay, for B it says, determine the values of x for which the function is decreasing. What we showed was that this actually works for us. So all we need to do is solve for x. Not too bad. So it's just going to be two different ways of getting there. You can either graph this and find the intersection of these two functions, or you can graph f prime and get the 0 where that is crossing. Either way, what you're going to get is x is approximately 1.17. And then you're just testing on either side of that. So test an x value, a y value as you like. You're going to get 0 less than or equal to x less than or equal to 1.17 is where it is decreasing. If you check out the graph of the actual original function, you'll see that that's true. Here's that graph, original function. There's my minimum, and you can see it's decreasing for all of those values. So you can use that. That's totally fine, because graphing calculators are allowed. Then it says sketch the graph of this and show the minimum point and any asymptotic behavior. So by all means, use your graphing calculator to get something like this. The asymptotic behavior you're going to get is that we can't ever actually hit 0 there because the sign of 0 is 0, and we're not allowed to divide by 0 because the world collapses. It's all very bad if that happens. By the same reasoning over here, a little bit off the graph that you can see right here, you'd also have an asymptote at pi, because where x equals pi, you also get sine of pi is 0, and so that gets a problem. So you have asymptotic behavior at x equals 0 and x equals pi. Those are asymptotes. Find the coordinates where the normal to the graph is parallel to the line y equals negative x. So that means that the line y equals negative x is right here, 45-degree angle, and our function, which kind of does a super flat bit and then comes up, sorry, writing on an iPad is not super great, somewhere around here you're going to get something that's parallel to that. So what we're looking for is a slope of -1. Oh, shoot, I mean a slope of 1. This has a slope of -1. This one has a slope of -1. But we want the normal, which means that we want the opposite reciprocal, which means we want the slope of 1. So we're actually looking for where there's somewhere over here is probably, we're going to get a parallel slope to that. So you're just going to be solving for f prime of x equal to 1. You're welcome to try to do that algebraically. Might be kind of a pain. I would probably turn to a graphing calculator here. So here is the original function graphed, the derivative, and then I just set myself y equals 1, and then I'm looking for where that slope is 1. So it's going to be right above there. So the x value we're looking for is 1.96 or 1.957, as you like. And then, of course, I did not catch this. We have not done the volume of revolution for this, so don't panic about 9e. We're going to probably get to that within the month. We'll get there. But you don't have to worry about 9e. Let me know what questions you've got.